Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful as you pass. Move along, move along. Come inside, the show's about to start. Guaranteed to blow your head apart. Rest assured, you'll get your money's worth. Really show it happened all right. You got to see the show.
Hi, and welcome to another session in our continuing MetalForming Live series of webcast panel discussions covering topics of interest in metal forming companies. I'm Lou Kren, Senior Editor at MetalForming Magazine at the Precision Metal Forming Association, and along with PMA President David Klotz, MetalForming Publisher Mike Volan, and MetalForming Editorial Director Brad Kuvan, and the entire PMA and MetalForming Magazine team, we're delighted to welcome you to this one-of-a-kind event made possible through the support of our generous sponsors: Schuler, SAE, Universal Robots, ECI, OnRobot, Pacific Press and Multipress, and PMA. Today's session of MetalForming Live explores automation in the press room with a focus on optimizing revenue per employee. Over the next 90 minutes, we and our expert panelists will tackle the why and how of press room automation, zeroing in on part movement, bin picking and part racking, automated press setup and controls integration, automation simulation, and sensing for automation. I'm joined here live at PMA's HQ in Independence, Ohio, by MetalForming's Editorial Director Brad Kuvan and our distinguished panel of experts. Before we dive in, I'd like to thank you all for attending today's webcast and invite you all to please participate by using your Zoom interface to ask questions of our panelists. And I want to thank our sponsors whose generous support allows MetalForming Magazine and PMA to provide educational events such as this. Please take a look at this brief sponsor video from Universal Robots. Then we'll have our panelists introduce themselves. Okay, thanks again to Universal Robots and all of our sponsors for supporting today's event. Now let's meet our distinguished panel of experts. Please introduce yourselves, starting with Will.
Hey all, Will Healy here, and I am Global Segment Manager for Welding at Universal Robots. I, of course, love that video. And I am also a board member at AMIP. It's a manufacturing workforce board in Cincinnati, as well as a content creator, Will Automate Online. So really looking forward to our discussion today.
I'm Paul Stewart from Linear Automation. This fall, I'll be in my 25th year at Linear's.
Good afternoon. My name is Todd Wenzel with TCR Integrated Stamping Systems. We're a systems integrator. We help our customers become more competitive, sometimes with whole new systems and sometimes just improvements of what they already have.
I'm Brad Kuvan, Editorial Director of MetalForming Magazine at PMA. Glad everybody could join us today. And thank you to our panelists for being here. We've got a couple panelists online, so we'll let them introduce themselves. Dean, why don't you go ahead and introduce yourself, please?
Thank you, Brad, and thank you, Lou, and of course, all of the MetalForming staff that has helped put this together. I'm Dean Phillips. I'm an innovation strategist and sales engineer for Link Systems. I also am the president of Longevity Industries. I am a board member for the SME, as well as a Smart Manufacturing Advisory Committee member. And of course, I am the host of the Destiny of Manufacturing podcast, powered by PMA. Glad to be here.
Go ahead, Dave.
Thanks, Brad. I'm Dave Bird. I work in the area of metals fabrication process improvement in metal forming, all metal forming processes and welding, and mainly through sensor-based error proofing and all of the connectivity and the stuff that goes with that difficult part of the whole process. So back to you, Brad. Lou.
Thanks, Pat. Thanks, panelists. Before we get to Will, we'd like to present this short sponsor video from Schuler.
What is it that you really want for the future? The latest technologies? Transparent machine data? Higher production and process safety? Straightforward support? The solutions in our digital suite enable your Schuler presses and external installations to be digitally retrofitted in a simple way. Transition does not always have to mean something new, so your installation can run even more efficiently and error-free in the future. We have developed the Control Retrofit, which includes, among other things, the Space Control Panel. The result: higher output, more safety, increased cost effectiveness. Ready for Industry 4.0. Unplanned machine breakdowns and high downtime costs thereby become a thing of the past. Would you like to have a tool that provides reliable machine and production data that can be accessed anywhere and at any time? Machine applications provide precise information for optimizing production and fast error analysis, whether it be the production status or relevant temperature data. Our Edge device transfers data to the Schuler Cloud, where it can then be viewed in the My Schuler portal on your smart devices. Do you want optimal protection for your tool? Visual Die Protection, our image-based tool monitoring system, recognizes foreign bodies and stops machines before expensive damages can even occur. The Upgrade VDP Analyzer enables you to analyze the error causes in detail afterwards. Do you need fast support? With Schuler Connect, we can assist you effectively and remotely during troubleshooting using smart glasses or a smartphone. Users simply connect with our experts and exchange installation data by image or video transfer in real time. Our hotline remote service will solve your problems anywhere in the world in no time, 24/7. Benefit from our digital solutions, whether it be our Space Control Panel, machine applications, Visual Die Protection and Analyzer, or Schuler Connect. And if it's additional services for more system safety and availability you want, you need look no further. Schuler Service makes your wishes come true.
Will Healy III is set to provide an overview of pressroom automation and how it fits into an effective metal forming operation. Take it away, Will.
Awesome. Thanks, Lou. I am really excited to be here to talk to you today about, oh, just kidding. Got to make sure the PowerPoint's actually clicked in. There we go. I want to talk to you about automation in the press room, and specifically about how do we really look at people and optimizing revenue when we're looking at a per employee basis. So should be an interesting conversation. We're going to reference some of the discussion today, but whenever I present, I always like to start with this. And it's really important. If you don't know your goals, you don't know where you're going, and it's really hard to decide what are the right things for our organization. And so I want you to think about, as you're watching the panel today, what are the goals of our organization? Are we trying to grow our top line sales revenue? Are we trying to reduce production costs, reduce scrap rates, or lower rework? Are we trying to improve our quality? Maybe we're trying to improve OEE or asset utilization or worker productivity. But really, I'm guessing you're probably looking for ways to find, sign, and retain great workers at all levels of your organization and to keep those workers safe and healthy in your organization. So what are your company goals? What are the major things you're working towards? What are the issues you're having right now? When you have those in mind as you watch something like our discussion today, it's really a powerful way to frame up and decide what's going to have the most value for us. Now, a couple of months ago, I was actually also on MetalForming Live, so I have to offer previously on MetalForming Live. We talked about Pressroom automation and from the press shop floor. There were two really great customers there or manufacturers there that clips and clamps and all of a sudden I'm playing Suka manufacturing. Thank you. I'm sorry about that. And they had some really powerful insights there. There were a number of panelists, but some of the things that we heard that they were challenged with was a rising number of part numbers. You know, that kind of changes the dynamic inside the production facility, more changeover and more complexity in our production processes. Material repeatability and making sure we have consistent material inbound into our process as well as going to the next process. You know, metal fabricators are really turning into technology companies. And that's really driving automation investments. And so how do we think about ourselves, not just as a manufacturer, but also as a technology company and the ramifications of that? And then I really loved this quote. I wish I could remember who said it. I just had it in my notebook as automation is an evolution, not a switch to flip. And I really like that because it's not going to happen overnight for you. You have to invest in that over time. And then last but not least, it's a mutual relationship in automation. You have to work with your integration partners as well as the manufacturer. There has to be an open dialogue and communication, or your automation application is less likely to succeed. So you have to have that kind of discussion and that kind of collaboration to be successful. So, you know, there are still, though, other major challenges, societal challenges that we're dealing with, that we're facing, that are causing issues. Things like, it's a strange economic time right now. If you read the PMI report that came out recently, 50% of the people that interviewed said we're having a terrible time right now, and 50% of the people said we're doing really well right now. And so that averages out to a strange middle of the road kind of situation in the economy. We also have, you know, things like the high cost of money and borrowing money. It makes us rethink what we're doing. And so we have to kind of think about what's going on and what is the total cost of ownership. Not just I have to pay a lot for a piece of automation, but if I don't pay for that automation, if I don't invest in that automation, what are the ramifications in the other parts of our company? What is the impact of that on our ability to succeed long-term as an organization? And so it's not just a money ROI, it's a full organization return on investment and a people return on investment that we really have to think about. And so we have this kind of strange economic movement right now. We also have workforce shortages everywhere, right? You know, there are 10,000 boomers retiring every day, according to the census. 10,000, isn't that crazy? And you know, we have 1.2 million unfilled jobs in manufacturing, warehousing, and logistics as of May. And what's really crazy is in food service and retail, they have almost 2 million unfilled jobs. It's like 1.7 million unfilled jobs in May. So, you know, we're offering benefits, traditional benefits. We're offering healthcare. We're offering 401k. We're offering tuition reimbursement. We're offering paid time off. But so is the Wendy's down the street from your factory, and your employees are seeing this, and Wendy's is offering a free meal. You're competing with a free cheeseburger, really. You are competing with that. And so that's an important thing to think about as we're looking for workforce, especially in our entry-level positions. There are these shortages everywhere. And I know this is a challenge for most of you because the National Association of Manufacturers published Q2 survey results last week. And in those surveys, like 74% of manufacturers said their number one priority was attracting and retaining talent. Not productivity, not quality, people is their number one problem right now. And so I know that this is a challenge for you and something that we have to think about. And those new generations, they have new expectations. They love this thing. It's their personal identity. Your phone number is more important than your social security number. I know because I just changed phone numbers and it was life destroying. So, you know, they have different expectations of what we're going to do as employers, how we engage with them. And we have to really understand that to be able to engage them well. And they expect technology. They wait overnight, 3 nights in the cold, waiting for the newest one of these things, right outside the Apple store. If you haven't invested in technology since World War II, you're gonna have a hard time attracting and retaining them. They have new expectations and they have an expectation of automation. And really, if you're having talent pipeline problems, this is negatively impacting your business, whether you realize it or not. You have idle machines because you don't have workers. Those are missed deliveries to your customer. Those are late deliveries to your customer. That customer is thinking, maybe we don't want to work with you again. And so you've got to think about what are those negative impacts on your business? How is that impacting? When you force people to work overtime, they miss their kid's soccer game. They might want to go work somewhere where they actually get to go see the baseball game or the soccer game or the football game. So we are having these negative impacts on our business, and we have to take those very seriously right now because it's not like it used to be. Used to be able to have one position, have 40 applicants line up at 7 a.m. outside the door and fill that position immediately. That is not the way it is anymore. We have 40 positions for every applicant now. Being facetious. So then, you know, how can we create a positive impact? And when I look at automation technologies in the press shop, and we're going to talk a lot about these technologies today, how do we create a positive impact in the press shop? Automation in 3 areas is really powerful. We're going to talk a lot about transfer systems today and how we move material in the press shop and the value that this can add very quickly to your press shop, to the productivity per employee, and generally to the happiness of your employees. We're going to talk about robots and cobots, and we're going to talk about other enabling technology as well. So when we talk about transfer systems, I'm going to leave the details to the more experienced folks than me, but generally there are a lot of different types of transfer, right? Sure, we've all seen the videos where people are reaching into a press, grabbing a part and moving it to the next station. You know, there are manual transfers out there. There's manual load and unload. There's mechanical systems where it's actually driven by the movement of the press itself to create transfer. There's linear transfers and robotic transfers and multi-press transfer between presses with robots and linear actuation. So, and then last but not least, what's kind of entered into the space is a cobot, which kind of sits in an interesting place between fully automated systems and manual systems. And we'll talk about that a little bit more. So we have, like I mentioned, we have the mechanical transfer systems like you see there from, somebody help me out, from Bob Gunts, the JCAR system, thank you. Sorry about that, Bob. And then you can see a linear transfer system here from Linear Automation on an Eagle press. So some cool things you can do with linear transfers and servo presses. We're going to talk about more collaborative robotics. I'm going to talk about in a few slides, but this is the ability, how much space do you have around your press? Sometimes you don't have the space where people and the automation can exist, and collaborative fits in a really interesting space there. And then you have traditional robotics that can do material movement in there. Then when we look at robots, I really have to acknowledge something first, that, you know, there's a lot of stigma around automation. You might be trying to bring automation in now, but your workers are unhappy about the situation. And so we have to kind of think about, what did traditional automation do in the past, and acknowledge that yes, the automotive industry, there was high volume repetitive jobs that jobs went away because they were automated. But in this new situation that we live in today, it's really not taking jobs because there aren't the workers out there to fill our positions. And so what automation is doing is it's raising the amount of productivity of individual workers, and it's raising the value those workers bring to our organizations when we bring automation in. And so, yes, did that happen in the past in that way that automation removed some positions? Sure. But in this new world order, in this new labor situation we're working in, automation is making the people you have more valuable. So traditional automation, this is, you know, typically can go a lot faster. It needs a well-defined process where you actually understand what's going on in your material. It needs consistent material to be provided to the process. Typically, you have a lower per part cost than manual processes, and it does require sometimes a significant upfront capital investment. When we look at traditional robots versus collaborative robots, this is not an either or situation. Each has their place. Where traditional robotic applications are really powerful, and you're going to see a lot of really nice traditional automation applications today. And there's also collaborative automation applications where that makes sense for what we're trying to do. So it depends on what you're trying to do. If you have lots of changeover and different part configurations, multiple changeovers in one day, collaborative robots might be a better fit versus a traditional automation application. But traditional automation, if you're running hundreds of thousands or millions of pieces of the same part and you need to run them fast, probably a more traditional automation application is a better fit. So it kind of depends on what you're trying to do, how much space you have, and what the application is to decide, is a traditional robot or a collaborative robot the right solution? So what is a cobot or a collaborative robot? The idea behind it is to do people-sized work, to do automation and to do work with the person and to do the physical parts of the job so they can focus on the smart and interesting parts of their job. This is a market that's been around 15 years. UR sold the first commercially available cobot in 2008. And the market now actually has more than 50 companies working in this space. It's now very established in a short period of time. And what I love about people-centric technology like this is it really puts people at the center, eliminates the boring parts of their jobs and makes their jobs interesting again and really engages the workers, which is going to help you with that retention and attraction thing that you're dealing with. And what I love is that last bullet you could see there was an MIT study from 2016 that said human and robot collaboration together is 85% more productive than robots alone or people alone, which is just mind-boggling. When we have people work together with a cobot, it is with automation, it's much more effective. Collaborative robots kind of sit in this sweet spot in the middle. Traditional automation, if you have real high volume, you might also require some decently good PLC or robotics experience. Manual work doesn't require robotics or PLC experience, but you know, collaborative robots kind of sit in that sweet spot in the middle. They don't require as much technical knowledge. They're able to do moderate to high mix of products at low to moderate volume and be effective in that space. So like I said at the beginning, this is not an either or, you do traditional automation or you do collaborative automation. They each have their space for what you're trying to do in your plant. Last but not least, I've got to point out one more robot that really you should be considering, and a lot of metal fabricators haven't paid attention to, and that's the autonomous mobile robot. These are the carts that move material around. This is an amazing tool. Most people think of them for Amazon or logistics centers, but as a metal fabricator, you're moving a lot of work trucks around with a lot of heavy metal parts, and these are safer in the work environment. They are more flexible in the work environment, and they're really able to do really powerful things for metal fabricators, moving material around the plant. This is a material movement discussion about transfers. This is about transferring material beyond the press, I guess, is what I'm presenting here. So. Moving on, enabling technologies. How are we enabling our existing workers is really one of the things I want to point out. And that really comes into some cool technologies that are out there that you should think about. I could spend our whole 90 minutes just talking about this slide, but I'm not going to do that. Lou's like panicking over there. But no, really, you know, there are things like exoskeletons. This may seem like science fiction. It is absolutely not. I'm seeing them all over the place right now. Exoskeletons allow the assistance of the physical parts of the job, lifting parts and moving parts. And so if you have people at the end of a press taking parts out of the press and then putting them on a rack or something, that's a physical part of the job. And you probably have some people getting injured from either repetitive motion disease or people just getting injured from injuries from that. So the next picture that you see there at the top is you see the guy in the Ford jacket. They're using drones in Ford in multiple plants to do a press inspection. Climbing up on the crown can be dangerous, requires work and man lifts and safety gear. So they're actually using the drones to do the inspection of the tops of equipment. So no one has to climb up there and look at it. They can look at previous historical video, compare it to current video, and then plan out the work up there so they only have to go up once. Really, really cool, right? That is incredible. Then in the middle picture there, you see a guy wearing AR glasses. Virtual reality and augmented reality, I'm just blown away by how real this is in manufacturing. Whether having a service tech remotely dial into your headset and help you service something, to opportunities for training the SME, Society of Manufacturing Engineers, Dean mentioned earlier, they've got this really cool virtual reality training whole curriculum inside virtual reality that's really powerful, and it helps people get on board and train faster. Really, really neat. And then, I mean, everyone talks about Spot the Robot Dog. But you know, there's a lot of these. They're called quadruped robots. It's a whole category now, and there's a lot of different ones of these. But the application for it to be able to do inspections, climb down into a basement and climb around and do inspections rather than having somebody go down there. Think of confined spaces. Anytime someone needs to enter a confined space, you could send the robot dog in there first, get your video, get your inspection, and then plan out what the work is going to be so someone only has to spend the least amount of time in there possible. Really, really cool what's possible with that. And then last but not least, this is micro location technology. How many times have you spent wandering around a plant looking for a bin of parts? We know we have 500. Our system says we have 500, but we don't know where they are. That happens everywhere. And so the technology is advanced. If you looked into it 2-3 years ago, I'm telling you, what is possible today was not possible 2-3 years ago. They could tell you sub-millimeter where something is when it's tagged inside a plant. Really, really incredible what's possible. And so there's some just powerful enabling technologies. But today in our panel discussion and with the other presenters, we're going to present all kinds of things like bin picking and part racking and part movement and press setup and simulation and controls integration and sensors and die protection and all these kinds of things that are really bringing automation as options into your plant. And so when you're looking at that and you're thinking about it, how to get started at the end of today's broadcast, I think you should think about what is your plan to succeed? What are those goals we talked about? What that we talk about today is interesting to you that you can write down and be like, that is the thing that we're going to move forward with. What is your plan to succeed? What I will tell you is even once you have an idea, start with the people who work in that area. Talk to them, understand what their issues is, what are their challenges, what are they working towards? Then understand what your process is, not what's in the book or on your website or in your intranet, but actually what they do each day. You'd be surprised how many steps in a process exist in real life that aren't actually documented anywhere. And then figure out what the product is you want to implement that solves those people and those process problems. Really, when you think about the people and you're talking to them, listen for things that sound boring or things that sound dirty and horrible or things that sound dangerous or that they might get injured doing those tasks. And then also dark. One of the lowest hanging fruits in a metal shop is installing better lighting and creating a more natural work environment inside the shop. I'm amazed by what a couple of LED lights and some better working conditions in those simple ways can actually, that's not even automation, but it's a technology investment that can be really powerful to advancing the way people think about you as an employer. And the other thing is as you invest in technology, you've got to talk to people. Technology is a tool, not a worker replacement. If you hear the rhetoric, that's going to take my job, that is going to take my job, this is going to take away jobs, we won't have as many jobs. That's not what's going on here. And so you really have to make sure as you're talking to them and listening to them, you tell them how important they are to you and that you're investing in this to make their lives better. It's a tool for them to make their work better. So this is what I want you to do as you're listening to us today. Think about what technologies we're talking about that will help you take a small project in your facility. Some people will tell you to find the biggest, boldest problem in the plant. I'm not going to tell you to do that. Go find something you can fail at a couple times that no one's going to get fired over, that you can figure out what works in your facility, and then really start investing in bigger ones. And the biggest thing you can do at the very bottom of that slide, I mentioned document the success. So make sure you track what was the cost before, what did you save, what did you save in time, what did you save in turnover of people? Like if you have a high turnover position doing a job, maybe you could invest in something that reduces the turnover. That's going to save the company money and time and headache and heartache. So really my question to you is, can you afford not to invest in automation? I don't think so, but I think my panelists would probably agree. But I'm now going to turn it back over to Lou. Thank you all for listening. I'm looking forward to the rest of our discussion.
Thank you so much for your insight, Will. And remember, we want this to be interactive today. So be sure to pepper Will and our panelists with questions that they'll answer in the Q&A portion of this webcast. Now, before we discuss specific automation topics in detail, please watch this sponsored video from SAE.
What SAE can offer you from a sales perspective is a couple of things. One of them is get to know you. Who are you? What are your business needs? What are the upcoming challenges that you may face? And how SAE can provide you with a full turnkey project.
It's a very large company, but with a small company feel to it. We have a lot of flexibility and capabilities for both our domestic side here at SAE America, as well as the support from our corporate overseas. We can really offer our customers a great value for our products to help them optimize their production, their ROI on the equipment they purchase.
What I feel that makes SAE unique is the fact that we basically try to help the customer, we help think for them and try to benefit what their needs are or anticipate what they need so that we can better serve them.
SAE has a very good product. We have a full complement of presses from 28 ton all the way up to 2,500 ton presses, and we have a full complement of parts in-house in Tennessee, and also have service technicians readily available to service all of our equipment.
And typically, whenever we receive a call for parts, we can get them out same day. We have probably 95% of the parts here in Tennessee and Mexico.
SAE has a very strong service department, very strong service team. We're able to resolve the issue for the customer so that they can continue making parts and continue on with their production.
From the point of finding a press project all the way after installation of the press project, we have excellent people at the factory, we have excellent people in the US, we have excellent people in Mexico that will help me help you become a satisfied customer.
Great. So let's dig into the automation details. First up is Todd Wenzel discussing part movement automation technology. Todd?
Good afternoon. Thanks for joining us today. What I'm going to be going through today is in a short period of time, a bunch of different methods of transferring parts through the presses, around the presses. As you go through, obviously we don't have a normal conversation back and forth now, but as you see things, they spark your interest, jot a note, send in a question in the chat, we can review them in more depth later. So I'm going to get through a bunch of material here and things we have to look at and consider as we choose different methods of automation. So that's one of the important things we have to do is when we walk into the application with the customer, we don't walk in with an answer. We walk in with a lot of questions. We need to understand, okay, where are we going with this? What's the right technology? What are the possibilities? So right now I'm going to show you some possibilities and things we do. And it's some of you'll recognize, and I think there'll be some maybe you're not as familiar with. So first off, traditional through window transfer. I think a lot of people have been around for a long time will recognize this as transfer. And this is how we always used to think, that's all we thought of when we thought of transfer. Right? Very large press, long transfer rail turns through the windows. It's an effective method of producing a lot of parts. There are some, like anything else, there's trade-offs. You say there's no such thing as a right answer, there's trade-offs. This is a wonderful way to make a high volume, a lot of parts. It requires a very large press, which requires a lot of capital. Even the foundation for a machine like this, like $100,000, right? But it has this place and where to be used, it's excellent. Another type of transfer like this, shown here, as opposed to through window transfer, we're gonna have a front and back transfer system. Another method using transfer rails before and after on both sides of the part train through, but the transfer is going to different. Again, there's advantages to trade off to this type of technique versus others. I'm going to advance the slide here a little bit. So one advantage for our front to back transfer is the transfer rails are shorter, which means they can be stiffer even at a smaller size, less mass to move. They can actually move very quickly. And so again, a similar process happening in tooling, but a completely different method of adding this transfer. This can go onto a press that doesn't have windows, for example. Or where we can't afford the press to get longer, there's obstructions on either end, or there's other reasons you will just go front to back instead. So traditional transfer, but done front to back. Here's a single-sided transfer system. Now this application is coil fed on one side. You see my cursor. So instead of doing a blank feeder, we're coil feeding. They're producing the first hit in the tool. The tooling has been built for the transfer to work. So you can notice the pass line of all the dies is the same. This is very important because we can pick up all the parts up and advance them together, which helps our throughput. Another project requirement here, which would be maybe difficult to see, but this component is bringing a component in. It has to be inserted into the part. So the automation is bringing in a part It's also, if you look in the background, as it exits, it takes a piece of scrap with it and drops into a scrap system. So in this application, a variety of things were needed, right? We needed to bring this part in, we had to introduce this other part, we had to find a way to eject the scrap. It worked out very well to use a single-sided transfer in this application. And I will point out, because this was made with compass line, allows it to simultaneously pick up all the parts up and advance them. And that's extremely helpful. This could also be done with individual die sets at different pass line heights. The challenge there is it's just slower. Right? It wasn't designed that way in the first place. Then they also, you have to go every transfer to pick up the part individually. So this is a system that was done for a client. That was the focus for them really was flexibility. Right? There's always trade-offs. It wasn't flat out speed. It was trying to remain as flexible as they can as a contract manufacturer. So we had to handle the contract that they had that was driving the project. They wanted flexibility for future application, what was going to happen next. So in this case, it's a tandem line. We're running the presses end to end. It allowed access to the front. If they want to, they can actually run hand transfer work in the front of these machines. It was actually configured on the safety side to allow us to segregate the three presses. Run all three together as one system, or you can run two, or you can run one. Once as built, it came with a destacking system. So we're doing blank destacking. However, the next improvement's already planned. It'll be a coil line going on the opposite side. So we can feed coil and transfer the other direction. So the flexibility here was one of the driving costs, right? Besides, we want to automate these functions, make them all in manual, but we want flexibility. So on the backside, it was designed so parts or scrap could be conveyed out at multiple locations. And so that's what drove that application. Now there's a lot going on in this one. This is a tandem line front to back. But right away, you can see that these machines are set up in a kind of an unusual fashion. These were installed long before automation was going to be a consideration. It was hand transfer. They left very large distances between the presses because they had to get fork trucks inside to load them. So these machines were spaced far apart. In fact, it made it very challenging for years for them to even consider automation because the distances between the machines was too great for traditional automations. Could be a real problem. So this application allows the use of this 5-axis robot. So one axis being across this Y beam in the back. There's multiple rotating axes along the way, enabling to move very large parts, very long distances. And that was the need in this application. You weren't going to be able to move several 1,500-ton presses and group them together and get them close together. Like if you're an automotive manufacturer putting tandem line together, it would look very different. This function built in the first place. This was designed as a retrofit. I'll advance a little bit. Go through here. So first thing, another thing you'll notice, you see the blank is passing through and it's offset. Well, it's a retrofit. There wasn't room to put it exactly in line because this end of the system would end up in the aisle. Things you have to consider. So just looking through the motion, this is not a transfer you'll see frequently, but it was extremely helpful in this application. The presses weren't on the same center line. They weren't consistent distances apart. The first one, it's considerably closer to 40 feet than 35. Well, not what you would normally think of if you were starting from a greenfield site, but it allowed us to take the existing machines and automate the line. Be very productive. This is what Superman sees with your invisible presses, right? But it was interesting how that worked out. I tried to show an actual video of the installation, but it turns out it was easier to see the animation that was done ahead of time than it was to do actual videos. So here's another tandem line. There's two presses that have been put end to end. Now there's a number of different technologies being used. There's a blank destacking system. Paul's going to be touching on that a little later in more detail, so I'm going to advance the slide a little bit past that portion. Yeah, it's easier said than done, apparently. There's shuttles in use in this, but first of all, in this main, first we have a destacking system. We have a front to back transfer. In this case, of this particular tooling is working in 2 axes. It's not using a 3rd axis at the moment. Then to connect those machines, as the materials are exiting this press, a shuttle is being used to traverse all the way to the next press. But you notice there's a conveyor system between them, which means if they would like, on the way, they can drop off a piece of scrap and convey it out. They can drop off a part. It could be a 1 press transfer system at this point, 1 and 2. So we have this flexibility built into this system, allowing the machines to be moved far apart, but actually still moving pretty rapidly because these shuttles move very quickly. Some of that video run. Moving along kind of quick here, not just because I have a lot of coffee. There is a running bet that I can keep this under 10 minutes. I don't know if I'll let or not, but I'll try my best. So in this combination of this line, there's multiple transfers. We have a blank destacking. There's shuttle systems going on. There's interest link, transfer in straight line, 2 axis at the moment. And there's even a stacking system at the end, which again, you'll hear about a little later in the presentation. So that line used all of the above as far as technology, right? It's using 3-axis machines, it's using 6-axis robots. And one of the things I'd like to highlight here is there isn't one solution that makes sense. There's trade-offs based on your needs, your existing conditions. Are we going to use existing presses? What kind of throughput do you need? How many shifts do you need to run? So all these have to be kept in mind. So I hope you saw some ideas. I'm going to trigger there, write them down so I don't run over my time. We'll come back later in Q&A and we'll be happy to address them. Thank you very much. Back to you, Luke. Like a
Thank you,
weatherman.
Todd. Now let's hear more about part movement automation, as well as automation simulation from Paul Steer.
Hello, and thanks everyone for joining today. So I'm going to talk about transfer systems, blank feed systems, turnkey lines, but also I want to talk about auto racking, kind of things that are trends in the industry today. And the big one today too is also bin picking. So, I mean, the bottom line, as vision systems become extremely sophisticated and extremely good, today is where these type of systems you can pull off a really successful project. So let's start with the transfer systems. The Linear produces through the window style transfers. As you can see in this video, this is a fairly large window system. About half of our systems are on brand new presses, and the other half are on retrofits, bringing new life. Like for instance, this press is from the 1988. Giving new life to the press. It's funny, the oldest press we've ever quoted was a 1939 press. So while Hitler was in Germany, invading Europe, this press was banging out parts. Never got the project, but it just shows you many of the presses were on from the 50s and 60s. But the retrofit, giving new life to old press lines is a big part of what we do also. This is just some video of the through the window style system. Advantage with a window system, of course, you can install sound doors on them. They're the more traditional systems. When you cross over to Europe or into Asia, this is kind of the only way they do transfer stamping is through the window system. You do have a lot higher visibility. Some of the disadvantages, though, is they create a much larger bar profile than you do on the front to back or front and rear mount transfers. And it's more difficult if you're doing takeover work. It's not quite as easy to do on these type of systems. Just going to buzz through this presentation because I'm just going to cut to the videos. So this is the other style, which is the front and back transfer. This is, in our case, where 70% of our sales are this style of system, because like I said, a lot of them go on older press lines that are around. This one you're seeing here is running like 42 strokes a minute. In today's world, the big change too is the servo systems no longer need to be the bottleneck in your stamping process. The drivetrains are scalable and modular. So therefore what we do is take your biggest profile, your heaviest part, and we build the drivetrain around that so that you can come back and look at the transfer automation as your bottleneck. We do the same with the blank destacker also. So in this case, we're seeing one run in a pick and place motion. So it's a Class A part. Remember that part because I'm going to show you an auto racking on that actual part coming up too. In this case, you can see the flexibility of one arm doing the transfer of with electromagnets, and the other arm is just catching scrap out of an upper die sheet. This is a front and rear in one of the larger beds. I think it's around 9 meters, this bed, left to right, and it's running appliance parts. just gonna, yeah, so this is a third, so this is kind of a trend. These one-sided transfers have become a fairly big trend in the last, I'm gonna say, 5 to 10 years. Quite often, you know, part doesn't have to be grabbed from both sides. You can get away with if it's a stiff part. And while we're talking about this application, we've done many of these just using a robot also. In this case, we're using a linear actuator, which is always faster than a robot, but in some cases, volume says you don't, that you don't have enough volume to justify a high-speed linear system. So that's another huge trend for us is lately, if you look at our shop today, it is loaded with robotic applications. Robots are a commodity. It's one thing that they have advantage. They're fairly easy to get off the shelf, and they do have a number of advantages. We just quoted a tandem line. It was legacy tooling, and in the third press, it had 2 stations. In the one station, you had to not only transfer the part, but you had to manipulate the part because they were hand transfer dies. And the robot definitely pulled that off better than a linear system. So the other thing is tandem lines. When you look at trends, tandem lines have become a very, like I've been doing this 25 years. I don't remember the tandem lines near as popular as they are today. I've been told one of the reasons for popularity, they're very easy to move, a tandem line versus a large bed press. These are some of the different ways to skin the cat. So that's one thing with tandem lines. There's multiple ways to skin the cat on tandem lines. There's a single bar transfer, and here's a bit of a video on different. So this first transfer is a loader unloader between the presses. This line actually has 11 presses, and you can see they're grabbing the part and loading it between presses. So that's a pretty common press to press style transfer. And coming up is a 2-sided transfer. So you can see that's a pretty long line. These guys run it like 5 presses sometimes. They run all 11 at sometimes. So here's a little faster type of transfer line for gap frames. This is a 2-sided transfer. Had these been servo presses, this would have even run faster. So this line, I remember quoting it at close to 18 strokes a minute. Had it been synchronized with all servos, could have run 25 strokes a minute. Here you can see that we are grabbing it from both sides here. So just another look at press-to-press applications. Then there's robotic transfer lines. This one here is a, you can see is so that we're going to talk about simulations coming up also, but this original project was quoted totally in a simulation, and we're able to simulate everything, including the scrap removal, the dryer that you see in this video, the stacking units. So I can remember the customer standing up saying, "Is this what we're getting?" And then this video actually is exactly the same as the simulation and running at the same speed as the actual production. So there's robotic. There's a good case where this line didn't have to run that fast. So robots were by far, these are FANUC robots, and were definitely the right application in this line. Some more press-to-press automation. This is as you get into the Class A for the OEM styles. This is a linear motion actuator rather than a robot, much faster than a robot. This we can run up to 18 strokes a minute for the dual arm, 16 strokes a minute for the single arm. So this is pretty awesome automation for press-to-press. We have a partner in Germany that makes the actuators. We install them for North America. Blank feed systems, about half of our installations do come with a destacker. Again, we don't want to be the bottleneck at the end of the day. We have magnetic overhead belt ones. We have vacuum pick and place ones, depending on the parts. But again, the big thing the customers want is continuous run. They don't want to be having to shut the press down. So, the stack builds up a buffer, and then we basically destack that buffer while they switch out the carts. Here's one that's loading into a shuttle. So this press actually came from one of the OEMs. It's a very large press. They wanted, it's a good case of reviving an old press. So we ripped out the transfer, did new press controls, new end of line destacker, our front of line and transfer system. This is just showing some carbon fiber press loading. Here we took out, this is a retrofit of a 1988, very large OEM press doing Class A outer skins. You can see those are carbon fiber rails. I wanted to talk quickly about layouts. A lot of customers for total flexibility want coil feed plus blank feeder. And there are a million different ways we can skin that cat, but this is kind of one of the examples of it. We are quite often dealing with I-beams in the plant and different layouts. But the key is to keep maximum flexibility at the end of the line. We do blank loading systems also for customers that do high-speed blank stacking. Here's another one, a robotic. So as you can see, in some cases we're using linear actuators, in other cases we're using robot. So this is the kind of what's coming is auto racking. And we have done a few of these at this point and some of our competitors, but this is kind of the future. I said to Brad, I said, you know, the Star Trek, Star Trek saying is the future. What is Star Trek saying? What's that?
Hopefully go where no man goes before.
Shall we go or don't we? No, the final frontier. That's the catchphrase I'm looking for. So in the press room, whether you're at an OEM level or tier 1s, tier 2s, this has not been, these lines of auto racking have definitely not, are not that common today, but the technology is there now. So we can get to auto racking at high rates. You can see, so there's a good picture of simulation also. In the bottom right corner, you can see the actual system and doing the count. So the big difference with simulations today is not only just simulates the robot, but the entire cell, the conveyors, the presses, the transfers, and they're really accurate versus what they were just a few years ago. Okay. And the key is the vision systems. There are a few newer vision systems that are cutting edge today. We're working with one called Blue Wrist, another one called Apera AI, very high-tech vision systems using some using high-def cameras with lasers and the combination in some cases. But the technology, I guess my story is there's no reason to wait. The technology is here today to do, if you're interested in bin picking, auto racking, it's here now. So that's, this is another one with cross members. So these are a pretty common part. But you can see these are cross members. The one guy from the AI vision system, he says, how many kids wake up today and say, gee, I want to do bin picking when I get older, or I want to rack parts, right? So the future is what you're looking at here in auto racking and bin picking. Just going to go to one slide at one video at the very end. This is a long presentation I can share with anybody who's interested, give you the entire presentation, but today we're all time limited. This little video here was one of the biggest home runs we had. Now it's a combination of a servo unloader and a servo press. This is a very large company that makes turbines, and these are the laminations. And so they're making these, when we walked in there, at 16 parts a minute, and they asked us how fast we could get with a servo press and a servo unloader, as you can see here. That system runs at 47 to 50 strokes a minute. So huge home run there. They had 4 presses, but it's just a good look at technology, you know, when you need, when you combine servo presses and servo actuators. So I'm gonna, the bin picking, excuse me, bin picking, how do I get to, you got it? Okay, thanks. Okay, I do want to show this as a bin picking video. Here we, you have a bin with random parts in them. You're either taking them from the press into a tote, perhaps, or you want to load it into a fixture for automating down the road. This is becoming a very popular application, but it's be really honest, it's not that common yet, but it will be. There's a lot of, this is a very taken away. It was interesting, the guy who does the vision system, he says, you know who's good at bent picking? Humans, because we have 2 eyes and we got arms. He says, but he said, this is where you just can't find humans. And this is just an example of some of the stuff we set up in our shop. But putting into totes, putting into fixtures, but this is a very futuristic application for metal forming also. Okay, I think that's it for my presentation, so.
Thank you, Paul. Thanks. Now let's welcome Dean Phillips to discuss press automation setup and controls and integration. Dean.
Thank you so much, Lou. I appreciate it. One of the things right away that you've heard so far, we've been talking about, is every single part of this is integrating and has the capability to integrate with the press. And when we do that, that's where we start to add value to the process, and also, more importantly, to integrate it into our stamping operations. So if we think about how we're going to integrate and what that means, well, the control becomes the brains of the operation. We don't just have a control that connects to a press. Today, we're connecting to all kinds of automation. And that's a very different system than we used to have. We're now able to communicate with all our ancillary devices. The hardest part is finding a common language. That becomes a challenge when we're starting to integrate. We find the same thing true when we're talking to our operation systems, our ERPs, when we start to look at those. But if we look at the press, let's just start where that is. We're gathering data. We are basically the IIoT aspect of the system. We're taking data from all different aspects. Sensors, we're taking it from machine controls, from motors, we're taking information from the sensors that you have on the dies, sensors you have out of the dies. The vision systems, as we were talking about earlier, that Todd talked about, and of course, Will mentioned, and of course, Paul had in there, it's that aspect of information that we need to gather in order to process the whole system. We often think about why are we having such challenges? 3 reasons: culture, culture, and culture. We think we know what everybody needs, but we don't ask people. Will had mentioned this in his presentation, which I think he did a great job with illustrating, is we have to find ways for our people to be integrated into the system. That means that they need to be able to feel like they're vested in this. We don't just start with, we're going to build this and this is what's going to happen. Never happens. There's a customer of mine that I have here in Tennessee, and for years, they knew one of the problems was that when they loaded one of the dies into one press, the other press was right across the aisle from it. So they had to back a fork truck up in that area. Well, what did they do? They stopped producing on this press when the other one was running, and vice versa. Everybody in the plant knew it, but it wasn't until they incorporated LinkNet and started to monitor how much downtime they had that illustrated the problem. Once they did it, within 6 months, they moved the machine. We think that we believe in our people, and we have that, but there's the old saying, I can't remember, which was for engineers, which is, in God we trust, all others bring evidence. I'm paraphrasing that a little bit, but it's an old engineering adage that you have to prove what you believe. And when we are talking about how we gather data, controls today, we can monitor just about everything on the press. We're monitoring the lube. We know when we're running low on lube, and we can produce a message to say, hey, you're out of lube, or you've got an error in that lube system, or you've got an error in how you're monitoring this sensor, or the sensor's bad, or those kinds of information. Now we have to get to the next level. Some systems will just give you an error code, then you got to go look it up, or you have to have a maintenance person come over. You need to have real world data. You have to have information that people can act on. I believe that the most important thing is when we gather data and we have controls is actionable items. So when it comes up on the screen, something has to say e-stop rear left. I need to know that I need to go to the rear of the machine and go to that e-stop in order to check to see if it's not been reset, or that there's an error. This also, through AI, can then be monitored for process errors. What I mean by that is when we start talking about process errors, there's things that people do a certain way, and people are creatures of habit. 3 out of 4 operators may enter into an area when they're setting the coil from the front. There's always the one person that enters from the rear. And understanding that action helps us to understand what the needs are for those people, whether it's being trained differently, whether it's that the things that we're doing don't require that person who's working on that die to operate the same way. So we have to find ways to work around the data and use it in the proper way. Action has to be driven by the information. We can integrate now with robots, transfers, any type of secondary operations. Things like, think about your process of how am I going to get information from a feed line, or from a transfer, or from a robot. All of those have integration aspects that the press needs to know about. Anybody out there want to raise their hand for how many times you've crashed a robot arm? A lot of people, even though you're probably not able to raise your hand, I can guarantee you that most people that have robots have crashed them because they're not getting the information from the press to the robot. That's a problem. That's an issue. And consequently, there's not the proper handshaking. Integrators like Todd, for example, Todd's great at integrating the system. Most people are not. Most people do not integrate. They say they do, but they don't. Consequently, there's no handshaking. Handshaking is, in control technology, a system of confirmation that I know that this was done. I know that the robot didn't feed into the press, or it's out of the press. I need to confirm that it's out of the press before I stroke it, or it gets to a point of no return where it's going to crash. Got a lot of customers that have crashed many robots, and it costs hundreds of thousands of dollars because the control isn't integrated properly. Information is not passed along correctly. We're not monitoring the things we should be. There's a lot of things that we think we should monitor, but we don't. The most companies out there that have die protection are only using 2 to 4 channels. That's really not a good thing. It's a good start. Don't get me wrong. It is a good start. But George Karamejev, who's kind of the guru that, rest in peace, he was such a huge advocate for what we try to do when we're gathering data from die protection. The system can't do things on its own. It can't view what's going on and not be told. Die protection is another area where we need to be better at. We need to get better at monitoring information, whether it's through a vision system, which is great. Vision systems are great. They have some challenges with lighting and things like that. So if the system can get the part out, we say die protection, but in reality, die protection doesn't have to be in the die. It can be outside. It can be an external process. It can be a vision system that watches as the part starts to come out of the die on a conveyor. That's where the vision system can be and actually see better, because you've got a slide moving up and down. Well, what happens? What happens when I go and I put my hand in front of my face? I create a shadow. Well, that's creating a problem on those parts and those vision systems. Our systems have to integrate better, and we have to find better ways of doing these things. As I mentioned, culture and getting people involved and them understanding the process is really critical to the success of any of your programs. Are you maximizing the multiplier of your employees? All the things that we've been talking about so far, all the automation should maximize the value of that employee. I'll say that again. It should maximize the value of that employee. We're not trying to replace employees. We're trying to find out how to use them better so that what they're doing is adding a greater value, whether it's through things like, as Will had mentioned, exoskeletons, or using drones so that we don't have to go into hazardous areas or don't have to lift as much in a perceived nature. We can use those to make people better. We're even now integrating with systems so that things are remotely operated. I'm sure some of you have seen some of the videos for using remote workers to drive forklifts, to go in, take parts out of dies, or take out the tool as you're removing it and moving it. Those kinds of things that can be done remotely to maximize the employees and enter into a workforce pool that we're not currently tapping into. People working remotely that we can use. A lot more people are going into these systems. I think that when we look at our controls, we should not limit ourselves to what we used to believe a control was. It made the press go up and down. That's a very short-sighted option today. Our controls get into the nitty-gritty with communicating between our transfer lines, get communicative with our link net systems, systems that are monitoring the data and our production numbers, but it also monitors why we're down. That's how you're going to justify it. That's what, as Will had mentioned earlier, one of the things is that document the success, because that's how you're going to prove it out through your plant. You do it on one press. Now I multiply it on several other presses. That's where your success is going to come from. And with that, I'll turn it back over to you, Lou.
Thank you so much, Dean. And here to discuss sensing for automation is Dave Bird.
Dave, you're muted.
On a good foot there. There we go. We okay? Pardon me, I'm just dumb.
Happens to the best.
I'm looking at this equipment, the sophisticated robotics and the transfer systems and presses and everything. I still play in a very humble kind of the low end of stuff. But think about it. How does all this equipment work? How do we make everything work synchronous and get the best parts out, use material wisely, and not have downtime? You got to detect it, right? You have to measure things. So we measure, detect, identify, and connect things, put them together with sensing systems out on the die. We use a lot of technologies to do it, but what we find in almost every stamping operation in the country, there's stuff applied that shouldn't be there. We use lasers in a flood, in a mist storm of die lube. We use the wrong kind of products in the wrong places. It's all application specific. And it just causes a lot of heartache. So how much downtime do we have in broken tooling and a lot of that stuff? The most effective sensor to use in any stamping operation that's actually applied very easily and very cost competitive is an inductive proximity sensor. These things have been around since the 60s. And they've evolved incredibly since then, and they play a huge role in stamping today. The hostilities are immense. We still have die loops, halogenated, non-halogenated die loops. We have slivers and we have chunks of metal and everything else involved. Welding, same thing, heat. We have BBs. We have a lot of friction kind of stuff going on, but we still do the same thing over and over again and expect a different result. But the way this stuff has evolved is just amazing. I was going to show you one. I think we have a video coming up. Double blank detection. George Karmedjev used to say it was the holy grail of stamping, being able to reliably detect multiple panels, multiple sheets of steel being stamped. And, you know, how reliable is it? Well, and what damage does it cause? It causes a lot of damage, right? Broken tools, just prematurely wearing tools. It's hard on the press and all that stuff. We used to use big pancake sensors, and with inductive technologies, the smaller the diameter of a sensor in a tubular product, the shorter the sensing range and the greater the switching frequency. But with these stamping operations, you had to use such a large sensor with a large coil to get any type of measurement out of it to correct it. So it was hard to implement. But in this video that we have coming up, there's an analog technology that blows my mind. We have customers that can put it in tight places. It's 18 and 30 millimeter tubular style, but we'll show you how we can reliably detect 0, 1, or 2 blanks, which might be of value to some people. So I don't know if we're ready for that video or not, but let's give it a whirl.
This is a quick demonstration to show the ContraNext Smart Sensor double sheet application. Right now we have our Smart Sensor plugged in with our green LED showing, and a lot of the parameters that we have set. Right now we're looking at no target, so we have 109% of our nominal range, which is 6 millimeters. We are going to go ahead and introduce a single piece of material. Our switching signal 1 is going to fire, but our output, as you can see, is still not triggered because we're not looking for 1 sheet. We're looking to determine if there's 2. So as I introduce the second piece of material, our switching signal 2 will fire off, which will also release the OSS1, which is our output, and trigger that output. So I'm going to introduce the second piece. You can see the LED has changed, and the switching signal 2 and OSS1 output have both fired. They recognize that there's 2 pieces of material instead of 1.
Thanks for showing that. Pretty straightforward, right? And it can be installed in some pretty tight locations just to eliminate a lot of problems with that particular issue. But sensing in general, it's all about common sense. And in the world of stamping and welding, it's all over the map. I don't see commonality from one customer, one location to the next, and it's constantly a problem-solving session and a process improvement exercise everywhere we go. But there's tools out there to cover cables at these new high-tech PTFE cables, either before or after installation with new installation tools. One of the coatings I'm working with, the gentleman out west, Steve Coulter with Weld Dynamics, he's invented a coating. It resists everything you can throw at it, BBs, slivers, anything. And it'll ignore a lot of debris that sits on the sensor face. But the point I wanted to make is in all of this equipment, you've got to have a reliable means of telling the controls what to do, like the nerve endings in your body communicating with the brain. Where is it? What is it doing? Where do you want it to be? That's what I wanted to get across today. Thank you.
Thanks, Dave. So we've got about 15 minutes left in our scheduled session. Of course, we'll stick around longer if you guys out in the audience have more questions. So please, let's use this time. Go ahead and use that question panel on your Zoom screen if you've got any questions for our panelists. I know we covered a lot of ground here, a lot of different ways that you can automate in the press room. I'll get the conversation with you guys going. Maybe talk a little bit about justification strategy that you see and return on investment. You know, I heard Paul say, you know, you could invest in a servo press. It might cost more upfront, but you get more productivity. Might be a longer payback window. But what do you guys hear when companies have to make those decisions about the return on that investment for, you know, 1 or 2 year return, maybe spend a little less money up front, or are companies willing to spend more upfront and maybe look at a longer return time frame? Todd, if you guys.
Well, I have some thoughts on that. When I was younger, and I hit hair on top of my head, not just the bottom. The justification was always reduction of manpower. It seemed like they were trying to reduce costs by reducing labor. And while that's still relevant, especially now the demographic shifting, it's a matter of maybe the machine doesn't run on a second shift at all if we haven't automated, because there are enough people. We can't get enough staff. So sometimes it's increased, it's almost more people are thinking much more now about increased throughput than reduced manpower. We can get so much more through the machine. Another thing that's certainly, if you're just new to automation, if you haven't been getting automation, you will definitely be asking your supplier. You know, someone like me or someone like getting calls going to be sitting at the table. You can say, how many parts a minute does it run? Well, my guy can run this many parts a minute. I'll tell you right now, you should measure how many parts a shift he can make, because the automation gets there and stays there over a long period of time. So justification, you have to think about it in terms of total throughput over time, not just how many, 1 minute at a time. It is remarkable if you look at, don't look at how many parts a minute they can make and what your improvement is going to be. Look at how many parts an hour or a shift they make. And the automation simulations, which Paul was showing, are remarkably accurate. They'll show you how it's really going to perform. Yeah. So there's at least some thoughts. And then it's also an extension of the working career of your staff. Yeah. If you reduce these manual tasks and take the work out of it, then by Wednesday or Thursday, they're not miserable and achy and tired. Yeah. And you'll find you have some very good operators with a lot of great tribal knowledge from the shoulders up who will extend their working careers for years because you've taken the labor out. Yeah. I don't know your thoughts you might have on that.
Yeah, one of the end of arm tooling simulation. That's one thing that's so easy to justify because it's not a lot of money per die set. 10 years ago, wasn't around. Today, a good company that you all know is TSIM. Investing in something like that, the return on investment's got to be extremely quick on that, because you can go from a bit of a disaster program to a very well run program where the transfer is running very quickly, no interferences in the die. That is small investment, major return. I would say that's one of the areas for sure. Another company that we're dealing with right now, they cannot find people to catch parts. They actually are in a high per capita income area, and they can't find people. So it's not a return on investment thing at all. It's they shut the press down or they automate the end of the line, right? It is not a return on investment. And of course, the robots go 3 shifts a day, and they don't. We all know the jokes about robots, right? So, but anyway.
Thank you. And Will, any comments?
Yeah, definitely. I think, it's really shifting from just the financial return on investment to what is these guys kind of hinted at it, but what is the whole company return on investment and what is the people return on investment? And those may be harder to calculate in a spreadsheet, but you can, if you have a high turnover position, you could probably calculate that in a spreadsheet, what it costs you to rehire and retrain those people. And if it's a skilled position and you have to use a recruiter to find those people, that can be a really expensive part of your business. It may not be in your operation budget, but it's in the overall margin of your company, and the P&L sheet is going to be affected. And so you really have to think about it as a whole company return on investment and not necessarily an individual department. Yeah. And then on the people part, I think extending the careers is really, it's a masterful quote, really. That is the trick, that if we can keep that knowledge in our company for 5 more years, we can get rid of the physical parts of the job and have them do the things that people are good at, and have the robots do the things the robots are good at, the automation do the things that they're good at. People hate dull, repetitive, boring things. I mean, I specialize in welding, but I had a customer tell me, I can see exactly in a 2,000 piece run where the welder got bored. Yeah. 2,000 pieces. Can you imagine welding 2,000 pieces? Yeah. Like, that job would be terrible, right? Sure. So I really like, it's about boosting productivity. A lot of our customers have the automation do one task, and the welder does something that's more compelling and more interesting, more challenging for a manual process. So finding that people return on investment, that full company return on investment, you got to kind of look at it that way.
Anybody else want to comment on that? The guys online or?
I will. I could tell you that talking about optimizing a process like that, we've often talked about press speed, and people will say, I need to get a press that's faster because that's the most important thing. No, getting more parts off of it is what's important. And whether that is through automation or maybe you use a servo press that has a varying stroke so that I can now run a limited stroke and just run back and forth. Those are the things that are going to optimize it. But so many times we've seen people say, I need a faster machine. I need more strokes per minute. Talking about a transfer system, years ago, Steve Sargent, who used to work with me at Niagara, used to talk about if I can keep that motion as linear as possible and moving in a straight direction, the better off I'm going to be. If we can get with the die designer and look at things like the guide pins and bushings and all of that, if we can optimize that, we're going to be far better off, because now instead of doing this, I have to go up, over, down. And the more of this you're doing, the more you're taking away from your production time, especially if it runs so slow that you have to run it in something like an automatic single stroke, and you're now wearing your machine out faster because it's not running in continuous anymore. Now it's running in single stroke operation. So by all means, we need to find ways to optimize our workforce, optimize our process, and optimize our machinery.
That's good. Thanks, Dean. I'm also interested in hearing what you guys think about workforce issues when it comes to automation. You know, the type of worker maybe that runs a press line is different than the type of worker who maybe has to program and maintain an automation system, whether it's robots or what have you. I've heard people say that, you know, while we've had record sales in recent years in robots, we also have record numbers of robots that are kind of sitting idle because they can't program them or maintain them properly. I'd like to think that we're moving in the right direction with that, with more robot technicians and whatever some of the other titles that new employees entering the workforce can get from a school when it comes to robotics. But what are you guys seeing in terms of the general level of knowledge and skill in metal forming operations when it comes to being able to program and operate and maintain automated?
I would say the technology for ease of programming just gets better and better all the time. And so that is remarkably simple. You know, it was very routine to have the staff on the floor program robots now. But the use of different techniques in the software, they've made it simpler to do. And as far as maintaining it, again, this into the industry 4.0, the access to the internet, have interconnected machines, so you can, first of all, remotely see what's happening, diagnose it, and you can operate. You know, it really fundamentally multiplies the power of the automation technicians for your OEM. But if they can dial in and see it, they can immediately see what's going on. Say, oh, here's what you need to do. Well, you're on the wrong screen. Why? So your issue is, as opposed to flying there, from another state or another country or something else. So that the technologies are all coming together to facilitate ease of use and ease of support and maintenance.
Okay.
And it is, you know, what Will had mentioned, augmented reality, something we use in our own service department, as small as we are.
Yeah.
But you know, where we can actually see that, we can see through the client's phone or through his headset or whatever, immediately help them rapidly without having to be there. So that's a level of automation to automate the skills, the multiple of how much our skilled trades people can do. So all these technologies are converging, and I think it's going in the right direction. So I don't know your thoughts.
I watched our guys actually run a transfer in China from our upstairs office in Canada. It's like you know, you knee shake a bit, but what Todd is huge. What you're saying there is being able to come in and remote diagnostics. And I mean, the key too is having the parts available if those machines are going down or you're having issues, having them available on the floor. But I think we haven't had an issue with, like, we install robotic lines in customers. They're actually pretty up to speed. We haven't run into that yet.
Okay.
And we're starting to install a lot of robotics, and our transfer units are so much easier to operate than they were in the early days. The program, I mean, they've bit more of a canned software for new people to get onto. In our case, we have, 4 levels of user, and we only allow the operator to get onto the first level, right? And then engineering and any catastrophic stuff that's happened in our history has always been where somebody has let somebody get into that engineering screen and they start creating. In the middle of the night, there's an issue. So that kind of training, at Linear, we set up an entire training center with all the 4 platforms that we have specifically for our customers to do major training prior to them. So the one thing I've seen over the years is training has become a huge thing of what we do. But the customers, from their point of view, they're very up to speed in most cases. So,
and certainly you have as the younger workforce comes in, trust me, if you can beat Call of Duty, you can figure out a program fast. I mean, it is remarkably intuitive.
Yeah.
Because the same generation is also writing these new softwares. So there's a real, I don't know, automation 20 years ago was maybe awkward and specialized with engineers on the floor. Now it'd be really strange for engineers around the floor. It's just not a thing. And you would never assume that you would be doing that now. So that's a great improvement.
Yeah.
And getting better all the time.
Getting better all the time, for sure.
Yeah. Well,
Yeah, I'm gonna take a different take a little bit and just talk about, in our community, we do have a shortage of skilled people. I mean, the traditional worker, we can take automation, but like somebody building a die set in your tool room, that's not somebody you can find off the street, right? That person is not a fry cook on Friday and a die builder on Monday.
Yeah.
So these kinds of challenges are long-term and ones we have to deal with. If you find somebody and hire them, it just means you stole them from someone else down the street, probably. So I think the way this gets fixed is through local action. And so you have to be active in your community. You have to be reaching out to the schools and providing tours at Manufacturing Month. And you have to be out in your community, engaging the community, showing them that manufacturing's cool, and show them this is made in our hometown. Like, you should be proud of what we do in this building, whether you know it's in here or not. So many manufacturers have this kind of closed door thinking everything we do is secret sauce. And I'm not saying there aren't, defense contracts or something like that, but I think we have to be a little more open to opening our doors and engaging our community in a better way, because that's the only way we're going to get people interested in becoming a die builder. It's the only way we're going to get people interested in becoming a welder, is exposing our own community, adults and children, what's going on in our plants. Because what we do is cool. What we do is cool. When you feel the vibration, the ka-chunk, 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 when you feel it, I mean, you're all smiling, right? Yeah. It's like, it's neat what we do. Can you believe we smash 2 giant pieces of metal together within thousands of tolerances and make
especially
parts?
When you're using automation and
Yes.
modern, if you want to use that word, state-of-the-art technology to accomplish that goal. Yeah, I heard somebody recently say, if you've got these automation systems in your plant, stick a video camera in the corner of the plant, and you don't have to zoom in so you're giving away your trade secrets, but show people on your website or on a YouTube channel what you're doing inside that factory that people drive by every day and have no idea what goes on, and to show them these high-tech systems. I thought that was brilliant. Brilliant idea.
You've got to do it local. If you're waiting for the PMA to fix all the problems, if you're waiting for the National Association of Manufacturers to fix all the problems, I'm trying to think of a Canadian one, but I'm blanking on all of them right now. CWS, is that one? No, anyways, oh, that's a welding society, right? I think, okay, good. So I did get one. If you're waiting for the National Association to fix it, they're going to help you, but they're not going to be able to do it. You fix it through local action that you and other manufacturers in your area do.
Before we go, I do want to give Paul a chance. You talked about the Final Frontier, your Star Wars.
I finally figured out.
Your Final Frontier. So you talked about bin picking and with vision systems kind of becoming pretty refined, and even I know they're a lot more affordable today than they were a few years ago.
What's not happening yet is people actually buying into it. They're not, but there's been a few. So it's some good examples out there. Auto racking, even at the OEM level, not most OEMs don't, like the big class A parts and that are not, they are racked by humans coming down the, so that's the final frontier.
What is the challenge?
So the challenge, especially with big tier ones, big OEMs, is the racks are legacy racks and they're not in the best of shape. So the robot does, you know, really has to know if a rack is bent and you got a big class A part going in there. So it's an expensive venture for them to cross over into that fully automated end of line. Easier probably for somebody who's brand new to it, like a new OEM, like some of the EVs that are starting up, who can develop racks right out of the gate. And but even the OEMs, if they invest in new racks and invest in vision systems that actually inspect the racks prior to them going into each time they're being used, they get inspected by a vision system. Because that rack has to accept the part, right? And so that really is the big reason why people don't auto rack. But I will tell you, there are certain OEMs, they auto rack everything. So it's not, it's coming. I think in 20 years, there won't be people at the end of process.
Well, and incorporating,
Right.
as you're saying, vision system, incorporating inspection of the part automatically as well.
Absolutely.
A lot of people are using the racking, person that's racking. They're also doing that final check. Yeah, is there a ding, is there a scratch, is there a full slug, is there a dent?
Yeah.
Right, so, and that's something the person's very good at. Oh, this is weird. Point at the stuff that's odd, right? So getting the vision system technology there and competitively priced now is very helpful. I mean, you can scan a part now and you can check out, you know, dents and dings that are thousands deep. You'll spot it in a second. It's crazy. You're making a topographical 3D map of the part as you're scanning it. And,
You
it's
got to give credit to the vision industry, has really exploded in the last 3-4 years.
Yeah.
And our guys that specialize in robotics, they really are excited about it because they're like, man, if we had this, you know, 10-15 years ago, it is the vision system integration companies that are really doing it, knocking it out of the park. Not just in metal forming, but
back to
everything.
Dave's comment, right? The sensors, right?
Yeah.
Now, these are the eyes, right? And,
Yeah.
and it's remarkable the advances in those technologies and how it advances these other technologies.
And they have different ways to skin that cat. Some use no lighting at all and just 2D cameras. Others use lasers and lighting, and they all have their. So it's really quite an interesting world, the whole vision system. When it comes to end of line, so that's why I think it's the final frontier. In automation, there's automation usually in the front of line, the middle of the press with automating the press, right? But that end of line is, in my opinion, is definitely untapped. Yeah, it's still it's gonna, in 20 years, I can't see people catching parts. So,
I really agree too. There's so much like individual manual load of one station presses, right? A C press, someone sitting on a stool, just reaching in a bin, putting parts in.
Yeah.
We can't afford to have people doing those kinds of tasks anymore. And
no.
so the ability to integrate a simple material handling robot or collaborative robot, doing the bin picking, getting it in there, getting it out, putting it in the next process. There's so many of those metal stamping applications.
Yeah.
And so being able to use bin picking for those
Well,
applications.
and the challenge is they're often smaller manufacturers. Smaller budgets. They're running low volume, high mix work. And so the advance of the technology, getting the prices down in vision and the prices down in the automation. So that it's, and the ease of use where it's approachable for a company with 50 employees or 40. To buy one and do it. And it is remarkably effective, but you have to make that first step.
Sure.
It's not as hard as you think it is now.
A lot of credit goes to the robot companies too, because they're far faster than they've ever been. Some of them are aluminum bodies, like they are far faster than they've ever been. Combine them with vision systems. There's a lot of magic.
All technology you'll see at FabTech.
Yes.
The solutions are there, right? You just gotta-
Definitely, they'll be there.
Yeah, absolutely.
All right. Well, we are at the end of our time, so I want to thank all of you guys, our guys online as well, for joining us today. It was really excellent conversation. Thanks to our sponsors, of course, and thanks to our attendees for joining us today. But it is the sponsors that really help us make all this available to you guys. Also want to thank our production team again, as we always do, for the great behind the scenes work that they've done to make this event so successful. Our event coordinator, Ali Miller, our marketing director, Drew Gutierrez, videographer extraordinaire, Christian Pogrica, and as always, our amazing director and producer, Randy Kish, who actually is celebrating his birthday today. So happy birthday, Randy.
Happy birthday, Randy.
Please join us next Tuesday for our next Metal Forming Live session on automation or fabrication for metal stampers. That's coming up next Tuesday. So we'll see you all then. If you haven't signed up yet, you can visit our website and metalformingmagazine.com and sign up for that last session on fabrication strategies for metal stampers. Again, Jim, thank you for joining us today, and hopefully we'll see you next Tuesday.
Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass.